this question here is question number 14 of exercise 1, alcohols, phenol, ethers of base 5. So here we have a question which says that an organic compound A with the formula C₈H₈O₃. So first of all, it's so much unsaturated because carbon, hydrogen are present in 1:1 ratio. So we can expect it to be like something which is cyclic with high unsaturation. Yeah, or you can assume that it is supposed to have an benzene ring, which we will calculate by taking the degree of unsaturation. Okay, so now it was insoluble in water, dilute HCl and NaOH, which I have mentioned here. A is insoluble in water, dilute HCl and NaHCO₃. Now, but it was soluble in NaOH, dilute NaOH, which when boiled and the steam distilled, the steam distillate reacted with NaOH to give an NO precipitate, which reacted with NaOH and to give an NO precipitate again. So overall, the precipitate here obtained is an NO color, and the alkaline residue, when it is acidified, it gives a solid B, and then the B is dissolved in aqueous NaHCO₃ with evolution of a gas. So identify A and B is our question. So let's first make a conclusion about what could be the structure of A. Now let's take the formula of A, C₈H₈O₃. So we are calculating degree of unsaturation here. Degree of unsaturation is calculated by taking the formula 2 times the number of carbons plus 2 minus of number of hydrogens divided by 2. So we have 2 into 8 plus 2 minus 8 by 2. We are going to get the value as 5. That means degree of unsaturation is 5 degree. 5 degree, it's a huge unsaturation component which we need to explain in the compound. So let's say we divide it into 4 and 1. 4 we can give because we are assuming it to be having a benzene ring. So benzene ring for 1 for cyclic structure and the other 3 for the double bonds. So 4 assumed to be equivalent to 1 benzene ring, and 1 we have to account for. Most preferably, since oxygens are there and we do have carbons also, hydrogen is a monovalent atom. So the only possible one for the one unsaturation unit is C₈O. So C₈O is present, benzene ring is present. So that is a possible one which we can take. Now coming to the reactivity wise, insoluble in water, insoluble in HCl and sodium bicarbonate and all. So we can assume that there can be possibility of an ester bond. Why only an ester bond? Because the carbons have to be taken into consideration, then followed by oxygens have to be taken into consideration. So for that reason, A with the formula of C₈H₈O₃ has to be having a benzene ring first of all. Then let's say it has an ester bond. So in that case, we can take methyl group because already 6 are done. 7, 8 because carbonyl group is compulsory. And then we are left with only 1 oxygen and hydrogen. So we are making it as a phenolic group. So the possible structure is this. So this is nothing but methyl salicylate. What we are going to have? Methyl salicylate. Methyl salicylate is a soluble in NaOH on heating, and it forms an yellow precipitate which could be possible. What we can take it as to be the respective structure wherein we are going to have the sodium salicylate to be formed because it is reacting with NaOH. So the product, that is whatever yellow precipitate is formed initially, should be sodium salicylate. Why sodium salicylate? Because on acidification of this is giving us an solid B which is having 3 oxygens retained. So automatically this makes it salicylic acid. So on acidification, the sodium salt is converting into what? It is converting into salicylic acid. Now this is reacting with NaHCO₃, sodium bicarbonate. We know that the ester cannot react with the bicarbonate, but the acid can easily react. So when it reacts, what is the gas evolved? Carbon dioxide gas is evolved. So carbon dioxide gas can be evolved. And what is the respective compound? The compound formed is phenol. So this is how the reaction can be understood. So A and B, if we take, it is phenol and carbon dioxide. Thank you.